Hello, everyone, and welcome to today's presentation. I'm excited to have you here as we explore the financial outlook for Sally's gas station. The title of our presentation is Revenue Projections and Growth Trends, and our focus will be on analyzing past sales data and forecasting future revenue. Over the next few slides, we'll look at historical sales trends, how we've used the forecast linear function to estimate future revenues, and what this means for the station's growth potential. Let's get started. All right, let's walk through how to use the forecast linear function effectively. First, you want to enter your known data points, specifically the years, which are your X values, and the revenues, which are your Y values, in adjacent columns. This setup makes it easier for Excel to understand the relationship between the data. Next, when you want to forecast future revenues, simply add the future years below your existing data. This way, your data set extends logically, and Excel can use this to make predictions. Then, to generate your forecasted revenues, apply the formula equals forecast, linear, X, known Ys, known XS. Here, replace with the future year you're interested in, and ensure your known Ys and known XS refer to the ranges of your existing data. This formula will give you the estimated revenue for that future year. Finally, to visualize your actual versus forecasted data, insert a 2D line chart or scatter plot. This visual comparison helps you see how well your forecast aligns with your actual data, and it's a great way to communicate your findings clearly. Connecting these steps together, you can create a robust forecasting model that's easy to interpret and share. In this final slide, I want to highlight some key takeaways from the course. First, we learned how to organize data effectively by using adjacent columns for X values, which in our case are years, and Y values, which represent revenues. This setup makes analyzing and managing data much easier. We also practiced extending datasets by adding future X values. This is a crucial step when it comes to forecasting, as it allows us to project future trends based on past data. Speaking of forecasting, we applied the forecast linear function to predict future values, giving us a way to make informed predictions grounded in historical information. Another important skill we developed was visualizing these results. We used 2D line and scatter charts to compare actual data with our forecasted values. Visualization helps us communicate insights clearly and makes complex data more understandable at a glance. Overall, these skills, organizing data, extending datasets, applying forecasting functions, and visualizing results, are all about making data-driven decisions and presenting our insights in a way that's both accurate and visually compelling. This final step really ties everything together, emphasizing how these techniques can be powerful tools in real-world scenarios.